All right, last rapid fire video here. We are looking at question type 6, linear quadratic systems. There's only one to do and one to discuss. So let's do it. First step, copy out your uh, equations carefully. 4x plus 3 is g of x. So let's copy that out. G of x equals 4x plus 3. Check it when I go back here. Yep. And then 3x squared plus 3x minus 7 is f of x. F of x equals 3x squared plus 3x minus 7. Visualize. Of course, visualize. This is a parabola. It opens upwards. It crosses at minus 7, and it's rising when it crosses, but gently so. So its vertex is like really close there, and it's doing something like this. Okay, this one, 4x plus 3. It's a very steep line. It crosses at 3, and it is rising like that. So I know I have one crossing where it's positive and one crossing. I would predict in the third quadrant where x is negative and y is negative, but I wouldn't be surprised if y was slightly positive. I bet it's close to 0. So let's find out. Okay. So and then these predictions again help prepare me to error check my solutions. I am interested in the moment when g of x, this line, is the same as this parabola, and it's the same there and there. So g of x is equal to f of x at the points of intersection. Let's find them algebraically. You could graph, but you'd be crazy. The graphing is really useful to get a quick idea, and then you check it with algebra always. Okay, equals 3x squared plus 3x minus 7. Okay, now move those over so that we can equate this to 0 and use our solving quadratic skills to find the values. What was that? To find the values of x that make that true. Okay, so I'm going to take 4x from this and take 3 from this. So I'm going to have 0 is equal to 3x squared minus x minus 10. So now I play a special x game to solve this by factoring. I can use quadratic formula at this point. I think factoring is easier in this case because I can see this factors. 3 times minus 10 is minus 30. I want numbers that multiply to minus 30 and add to negative 1. Those numbers are minus 6 and 5. It's almost like someone created the question so that they would do this. All right, so let's go. 0 is equal to 3x squared minus 6x plus 5x minus 10. This will common factor 3x out times x minus 2. And this will common factor 5 out x minus 2. Same binomial factor appears in both places. This is equal to 3x plus 5 multiplied by x minus 2. Cool. Now I can see my x values. So x is equal to 2. That's from this. Or 3x plus 5 equals 0. Subtract 5 from both sides. 3x equals negative 5. Divide both sides by 3. X is equal to negative 5/3. That's one x value. That's one x value. So let's write them out carefully again. X is equal to 2. You don't need to burn a whole piece of paper just to do these questions. You can write a little smaller and more organized than me. X is equal to minus 5/3. Let's use g of x to find those intercepts. It was 4x plus 3, if I remember correctly. Yes, it was. So let's input them. G at 2 is equal to 4 times 2 plus 3 is equal to 11. Therefore, 211 is the solution. Check your visualization. That could very easily be the point 211. Over 2, up 11. Cool, I buy it. I think that's likely true. Okay, now check g at negative 5 over 3, which is equal to 4 times negative 5 over 3 plus 3. Okay, this is equal to negative 20 over 3 plus 9 over 3. That's the number 3 written as with a common denominator so that I can resolve this to negative 11 over 3. Oh, that's cool. 11 showed up in two places. Almost like someone was having a laugh when they created this question. All right, so now I know that the point negative 5 over 3, negative 11 over 3 is another solution. If I put those on a number line, those would be negative 2.7, and this is negative 3.7. 6 repeating, of course, but I mean, you're pretty close with 0.7 there, all right, if you're going to graph it. All right, and then check your visualization. Okay, that's this point down here. It turns out it's not down there. It's a little bit more like that, okay? But notice how useful that visualization was just to confirm that, yeah, we got the right stuff there. You can then algebraically check your answers on the test by plugging this point or this point, if you accept a little bit of error, into the quadratic and seeing if it computes, and plug that point into the quadratic and seeing if it computes. They do. So these are correct answers. Last question on the review sheet. How many solutions can a linear or quadratic system have? Draw a graph for each possible situation. Okay, so there can be as few as 0, as an interesting case 1, and as many as 2 solutions. This is what 0 solutions would look like. Draw a quadratic, draw a line, they never touch. This is what 1 solution could look like. Draw a quadratic, draw a line that touches once and exactly once. It's tangent to the parabola. It only kisses it. Okay, and then 2, well, 2 is easy, like that. 1, 2. Okay. So this is how a linear quadratic system can have 0, 1, or 2 solutions. They correspond to cases with the discriminant, okay? The discriminant is part of the quadratic formula. Because it's under a square root, we don't mind if it's 0, but if this is a negative number, if this is less than 0, then we can't take a negative square root. We can't take a square root of a negative number, so it misses. Graphically, it misses. Algebraically, does not compute. If we have exactly one solution, b squared minus 4ac will be exactly equal to 0. That means you have 2 solutions, but they're plus or minus 0 away from each other. They're the same. I'm 42 plus or minus 0 years old. I'm 42. Okay, doesn't matter if you add it or subtract 0, it's the same. And then here you have b squared minus 4ac. You have a discriminant that is greater than 0. That's what creates the separation between your solutions and gives you 2 solutions because it's plus or minus a real thing. All right, any and everyone, thank you for showing up for your learning in a continued manner. Any questions, absolutely hit me up by email, and I am out otherwise. Bye for now.